All right. So what form is that line in? It's a linear, but there's multiple forms of linear. It's y equals
2x.
We did it like a zillion times in Algebra 1.
mx
Mx plus b, right? Don't forget your mx plus b. And what two pieces do you think you need to find? Your m and your b. And that will let you graph that, right? And then what form is the bottom one in? Quadratic, and it's in vertex form. So if you find your vertex, use your stretch, you'll be able to get that one on there, right? And then once you get those two on there, we'll get started. All right, so this is y equals mx plus b, and the two things we need to find to graph this are our m and our b. So first thing you want to do is think about what's my m and what's my b. And for that, you just pull them right from the equation. What's in the m spot? 2. And since we're graphing, a good way to think of it is actually what?
2 over 1.
2 over 1. That gives us that rise over run. Remember that? The rise and the run, right? And then our b is what? -7. Now, I forgot to mention, this graph isn't perfect. You have to kind of go off the graph to get your b. Bad graph by Teacher Pachon. So we go down here, all the way down here, and you kind of have to add this. But it's okay because you know that your next point would be rise over run up 2 over 1, right? That's what 2 over 1 tells you. Go up 2 over 1, up 2 over 1, and then you get plenty of good points to graph with, right? Up 2 over 1, up 2 over 1. Now, we always want to be nice and precise. In this case, it's super important because of what we're going to try to find here. Make sure you get a good line in there that goes through all the points with a straight edge. Otherwise, you won't be able to find what we're looking for. Okay. And there's your line. Right there. Okay? So that's your line, right? And then your other equation was in vertex form, right? I don't know why I did that in blue when the vertex I wrote is, that's confusing. This will be our blue equation. And we'll make this one green. So what's our vertex here?
3, -4.
Yep. It's 3, -4, right? And what's our a value? What's our stretch? 1, meaning it's going to behave like a normal parabola. It won't stretch over 1 up 1, over 2 up 4, etc., right? So we go to our vertex 3, -4, which is down here. And I'm going to go over 1, up 1, back 1, up 1, over 2, up 4, back 2, up 4, over 3, up 9. It's all the way up here and back here. And then I draw my parabola through there. Right? All right, and then you were asked a couple questions. The questions being, what do you notice here? And does this remind you of anything? Anything we've done before? Yeah, go ahead.
Well, first we had to use y equals mx plus b to find
Mm-hmm.
Don't you have to find them? Just something we've learned already.
Mm-hmm.
The other thing is the fact that 2 sections intersect both of them.
Intersection, that's definitely important. Where does this thing intersect?
Points
At
and 6
2, -3,
and 6, 5
6, 5. And those are both what?
points.
Points. What is a point made up of?
X
An x and a y, right? So what do you think is significant about both those x and y values?
They keep their points of intersection.
They're points of intersection. That's the graph. But talk to me about the equations. What do you think is true about both of these x and y values?
They both go into the y place and the x place.
And they would make the equation true, right? Which equation would they make true?
Both of them.
Both of them. Are there any other points that make both equations true? No. We know that because that's the only 2 points of intersection. Does anybody remember what this is called? All right. So we'll pause and look at an old example. Ready? Let's say I gave you two linear equations. Y equals x plus 2 and y equals negative x minus 4. And I asked you to put them both on one graph. One's already on there. One's about to be. Ready? Where's their point of intersection?
Right in the center.
Negative 3, negative 1. What's true about that point? That x and y value.
It's true in both equations.
Right. So if I put in negative 1, does that equal negative 3 plus 2?
Yes.
Yeah. And negative 1, does that equal negative 3 minus 4? It would be positive 3 minus 4? Yeah. So it's a point that makes them both true. Is there any other point that you think would make them both true? No, because that's where they intersect. So this is a what for both of them?
The solution.
A solution to both equations. When we have more than one equation and it's a solution to both of them, we say it's a solution to the
Product.
also starts with an S? No. What do we call it when we have more than one equation?
Sequence.
A system. A system of equations. Sound familiar? Systems of equations. So we had systems of equations when we had two linear equations, and we found one. We either found one infinite or no solutions, right? Remember that? Parallel lines, no solutions, same line, infinite solutions, crossed, one solution. But when we have a quadratic involved, the possibilities are different. You could have two solutions like we had in our example, right? So I could have two solutions here, 1, 2. Is there any way to have one solution, you think? What would one solution look like? Right, what if I had this and then it just touched it like that? That's one solution, right? Is there any way to have no solutions?
They just never touch.
Yeah, and by the way, it doesn't have to be just a line and a quadratic. What if I had something like this, right? Two parabolas that just never intersect, right? So those are the three situations we're dealing with this time. Two intersections and two solutions, one or none, okay? And we need to know how to find them both graphically and algebraically, and that's what today is about, okay? So we're going to dive right into the lesson today. I know that maybe you had some homework questions. Hopefully we'll have time at the end, okay? Because I just want to make sure we get through it because it's our last one before the test, and we need to make sure we get through it so we can review tomorrow. Okay, so here, does this remind you of anything? Well, I was hoping it would be systems of equations. And what was important here? What ended up being important on the graph?
The intersection.
The 2 points of intersection. Because they are what? There are solutions. So 2 points of intersections, that means two solutions. And what were our two solutions in this case? 6, 5, and 2, negative 3, right? So system of equation, two solutions. It's the two things that would make both of these equations true, right? If you plugged in 5 for y and 6 for x, both of those equations would turn out to be a true statement, okay? Now, finding them graphically, I won't say it's simple, but it's straightforward in that if you could graph them, you just find the points and then you're done. You have your solutions. But you remember when we had linear, we didn't just find them graphically, we found them two other ways. No, this was systems. So we had three methods: graphing, substitution, and elimination, right? So we're going to use those same methods, right? And we're going to go through examples of different scenarios and what you might expect when you use those three methods, okay? So, ready? Okay. So you don't have these like lines on yours. I added them after I made the copies, but I'm going to write notes over here and the work over here. So if you want to do the same, you can make your own lines. All right, so our two equations were y equals 2x minus 7 and y equals x minus 3 squared minus 4. Okay? And we're going to do substitution first. Substitution. All right, so your first step, and you might not, for substitution, you might not need to do this. It might be done for you. In fact, in this example, it's done. But the first thing you want to do is get y by itself in both equations. So get y by itself in both equations. So you might need to move stuff around. In this case, we got lucky. And a lot of times we get lucky. That we have this equation, y is by itself. We have this equation, y is by itself. We're good, right? So step one is checked off, right? Step two, well, if we know that they're both equal to y, right, we can substitute y for y and set them equal to each other. So step two is we set the equations equal to each other. So what does that look like? Well, instead of, if I know this is y and I know this is y, well then that is equal to that. So I can say 2x minus 7 equals x minus 3 squared minus 4. Well, why do that? What have I gotten rid of? The y. So now I can just solve for x, right? Well, how do we solve for x? Well, you'll see. We already know how. Okay? Now, in this case, what form was the quadratic in? Vertex. You need standard form for this. So we're going to convert the right side of the equation to standard form. You most of the time won't have to do that. Just in this example you do. You'll see in the other ones it's already in standard form. So let's real quick just convert this to standard form. Just this side, right? So the 2x minus 7 will come down. How do I convert vertex? I pull it apart, right? X minus 3 minus 4. 2x minus 7 comes down again. I FOIL this, and I get x squared minus 6x plus 9 minus 4. And then I just bring the 9 and the minus 4 together. 2x minus 7 equals x squared minus 6x plus 5. So I've gotten that right side to be a standard form equation now. Now why did I do that? Because now I have like terms everywhere. I don't have the parentheses squared. So now I can do something to solve this. Now, whenever we have x squared, and there's also a bx term, how do we solve? What is the first step that we always did? We got everything equal to 0, right? So if I get everything to one side, won't the other side be 0? Right? So what I want to do is move everything to one side. Now you want to move to the side that the x squared is already on. You don't want a negative x squared. So move everything else to the other side. And you don't have to do it in steps. You can just say, well, I need to move 2x and minus 7. So I'm going to minus 2x and I'm going to add 7. And I'm going to minus 2x and I'm going to add 7. Okay? Now, on the left side, I'm left with just what? 0, right? These cancel, and I have 0. And then x squared, wait, why did I write the negative 2x and the plus 7 over there? And not just right here. I wanted to stack my like terms, right? Make it easy on myself when I do this next part, right? Because now I can see x squared doesn't have anything with it, so that's just x squared. Minus 6x and minus 2x is negative 8x. 5 and 7 is plus 12. Now look what we have. X squared minus 8x plus 12. We know how to solve that, right? It's in standard form. It's got an a of 1. It might be factorable, so I'm going to try what? Magic X, right? So let's see. I got 12 on the top and minus 8 on the bottom. What two numbers multiply to give you 12 and add to give you negative 8?
Negative 6 and negative 2.
Yep, -6 and -2. So this becomes 0 equals x minus 6, x minus 2, right? And now I can solve for x. What is x here? X equals 6 and x equals 2. Now, what were we trying to find here? What was the whole goal? We wanted solutions to the system, right? What do solutions usually look like? When we found them on the graph, what were they?
X and Y.
X and Y.
They were in intercepts. They were just points, right? So we just found part of our answer. What part did we find? X, right? We know we got 6 something and 2 something. Those are going to be our solutions, right? We have our x of each one, but we don't have our y. How could I find my y? Plug it in, find your y. And let's get back to our steps, because I kind of got ahead of myself here. Step 3, after we set them equal to each other, was solve for your x's, your x values. And now we want to plug in our x values to find your y values. And I'm going to add a little caveat here. Choose the nicer equation. Like, when I'm plugging in these x's to find my y, should I choose 2x minus 7 or x minus 3 squared minus 4? Either will work, but the first one's going to be a lot less work, right? It's just a linear equation. So I'm going to plug each of these in to find my y, right? So we know y equals 2x minus 7. What was our first x? 6. So y equals 2 times 6 minus 7, or 12 minus 7, or 5, right? So when x is 6, y is 5, right? So I know I have the point 6, 5. And then I'm going to do it again. Find my other one. Y equals 2 times 2 minus 7, which is 4 minus 7, right? Which is negative 3. So when x is 2, y is negative 3. And take a look at our graph. Tell me if we did well there. Did the solutions match what we found when we graphed this thing? Yeah, exactly, right? These are the x and y values that make this true, right? We use systems of equation substitution to find them. The only step I will add here at the end is state your solution or solutions as points. A lot of times students do this work, they do everything here, and then they don't say, here are my solutions. My solutions are 6, 5, and 2, negative 3. That shows you know that they are 2 points, 2 x, y values that make the thing true, right? Also, a lot of students solve for x and then they walk away from the problem. Don't forget, you need an x and a y for a system of equations, okay? All right, so that's substitution. You get the y's by itself, you set them equal to each other, get everything to one side, solve your x, plug it in, find your y. Okay? Ready for elimination? Okay. So elimination. Well, if you remember with elimination, we would stack our equations and we'd add them together and hope that something eliminated, right? So we're going to do something similar. First, we do want to get y by itself. both equations. That's still the first step. And I will say, if you're looking at two problems and y isn't already by itself, but you can kind of stack them and you see that something's already going to offset and eliminate, go for it. Like on your homework, you might see that. All right, and then the next thing we want to do is stack your equations with like terms and I'll use that word stacked again. So our equations are, and I'm going to use the standard form that we found, x squared minus 6x plus 5. And then my other equation was what? Y equals what? 2x minus 7. And I stacked the like terms underneath each other. So negative 6x, I'm going to put the 2x right underneath it because that's a like term. 5 and negative 7, I'm going to put them right on top of each other because those are like terms. Question?
Is this elimination?
Yes, this is elimination. I forgot to write that. Elimination. Okay, so remember with elimination, it was about like, hey, we add them together and then something eliminates. Right now, would something eliminate if we added these together? No, I'd get 2y, x squared, some x's, like nothing's going to eliminate. What could I do maybe to make one of them eliminatable? Yeah.
Multiply 2x by negative 1.
By a common factor. Wait,
So what's really close? Remember what's really close to being eliminated here? Y or x?
Y.
Y is, because x, I would have to eliminate both of these. But if I can eliminate this, just this y, then I'm in good shape. What would I want this y to be?
negative
How do I make it? Negative y.
multiplying it by negative.
Multiply everything by negative 1. Okay? So we're going to multiply everything by negative 1. This will come over, y equals x squared minus 6x plus 5. And then this will become negative y equals nothing, and then minus 2x, and then plus 7. And now if I add them together, something will eliminate, right? So if I add these together now, y minus y is what? 0 equals x squared and nothing is x squared. Negative 6x and negative 2x is negative 8x. And then 5 and 7 is 12. Does that look familiar? Same equation we got up above. So we already did this, but you would say 0 equals x minus 6, x minus 2. Solve for your x. You don't have to write this down again. You can just write same as above. So at some point it becomes the same. Right? It's just about getting to a quadratic equation you can solve. Okay? So those are your two methods, right? You can either set the things equal to each other, get everything to one side, and solve. Or you can stack them and make it so one of them eliminates, get a new equation, and solve that. And then once you do, plug it in to find your y's, and then you're done. Okay? Make sense? Or do we have questions? All right. So I want you to try the next problem, and then we'll come together and we'll go over it together. Okay? And tell you what, you do the substitution and elimination. I'll do the graph for you up here, so you don't have to do too much of that, because you've had plenty of practice with graphing. And you can copy my graph to check your work. Okay? So you go right into substitution and elimination. So like I said, you can just copy my graph. I don't want to spend too much time on graphing because that's something we've done a lot of, right? But you can see that now you know the solution from the graph, and you can use that to check your work when you're doing your work for substitution and elimination. So if you're doing substitution, well, you would get them y by themselves. They already are. It's going to happen a lot. And now I just say, oh, okay, y, well, not y, negative 2x plus 7 equals x squared minus 6x plus 11. We know the only way to solve this for x is to get it equal to 0. So we got to move stuff to one side, move it towards the x squared. So I would say, okay, plus 2x minus 7 on both sides. That gives me 0 equals x squared minus 4x plus 4. If I magic x this, I have 4 on the top and minus 4 on the bottom. What are my numbers? No, negative 2 and negative 2. That wouldn't give me both the combination. So that's 0 equals x minus 2 times x minus 2, which is the same answer twice. It's just x equals 2. And that means there's how many solutions here? Just one solution. I only need to plug this in once. And I have to plug it in to find my y. And I'm just going to choose the equation y equals negative 2x plus 7, because that seems like it would be an easier thing to do. So I just plug 2 into that. Y equals negative 2 times 2 plus 7. Y equals negative 4 plus 7. Y equals 3. So what's my solution to this system? Remember, a solution is a point that they both have in common. And I just found an x and a y. Go ahead. Yep, my solution is 2, 3. And if you look over at the graph that I did for y'all, if you want to copy it down, well, 2, 3 was the only point that they intersected. This line was here, and then the parabola came and it touched it, and then it went away. Right? It only had the one point of intersection at 2, 3. And we confirmed that using substitution. Yeah. Yeah. All right, if we did elimination, real quick, I got y equals x squared minus 6x plus 11. And then I know that I need to, so I'm going to skip a step here in the interest of time. I know that I need to negate the entire other equation, right? The y equals 2x minus 7. Was that what it was? Negative 2x plus 7. I got ahead of myself there. So if I multiply this all by negative 1, it becomes negative y equals positive 2x minus 7. And then I add that all together. Right? I'm just multiplying the second equation by negative 1. When I do that, I get 0 equals x squared minus 4x plus 4, and we already did that math, right? See above. At a certain point, you get to the same part of the problem, where you just have to solve the algebraic equation for your x value, plug it back in to find your y. Okay? So either of those will get you there. You got to get to a point where you can solve a quadratic equation. Question?
Can you scroll up the time a bit, please?
Yep.
How do you get the
I plugged in the 2 into the y equals negative 2x plus 7. I gave you my y.
So say they were different numbers, not just 2. How would you know which one to pick? Or
I'd have to plug them both in. Like we did in the first problem, we found 2 answers. So this one only had 1 answer.
so we got like
Yeah.
Are we going to have to solve with both substitution?
You'll get your choice on the test. All right, so next one, again, we only have about 5 minutes, so I'm just going to show you what the graph looks like, okay? And you can copy it down. You do want to be able to graph standard form, though, so just make sure that's something that you, if you don't know how to do, that you're practicing before the test. So these graphs look like this. So that's this one, right? Again, I have the answers, I'm using them. This graph looks like this, and they don't touch. So what's that mean about our situation? What's the solution to this system? This is a no solution. There's no solution to this system, but you're right that imaginary numbers will come into play, and I'll show you what I mean. So if we were to do substitution here, where we set them equal to each other, right? We would say, okay, x squared plus 4x plus 5 equals negative x squared plus 8x minus 12. And then we said that we wanted to get, when we have a quadratic, we want to get everything equal to what? 0. Well, I need to either move everything here over there or everything here over there. Well, here's the thing. I don't like negative a values. I already have a positive one over there. I know if I move this over, it'll just make it more positive. So I'm going to move to the left. It's all right. So I'm going to add x squared minus 8x and add 12 to both sides. Add x squared minus 8x and add 12 to both sides.
Would it be 2x squared?
Yeah, it will eventually. These cancel out, and then I end up with 2x squared minus 4x plus 17 equals 0. And I have to solve that for x. Now, right away, I see I have an a value that's not 1, and it's not a GCF. So I'm thinking I'm probably going to either rainbow method or quadratic formula this, right? But I kind of want to know which one it is. So how do I know if it's factorable or not? What tells me? The discriminant, right? The discriminant will tell me if it's factorable. If it's a perfect square, I can factor this thing. If not, I'm stuck. It will also tell me one other thing. We'll see what that is. Okay, so the d in this case will be negative 4 squared minus 4 times 2 times 17, which is negative 120. So what does that tell me when your discriminant is negative?
It's one real solution. Oh, wait.
That's 0. 2 imaginary solutions. Okay, so think about what that means. Oops. Think about what that means. That means if I actually went to the quadratic formula and I did all the work to find my solutions here, I'd get stuck with I in it. And then we find our x and we plug it back in to find our y, but our x's are imaginary. So I wouldn't be able to find a real y either. So I already know the answer to the question, right? The question was solve the solution to the system, or find the solution to the system. If I have an imaginary x, I'm not going to have a real y, so that means there is no solution. So if you use b squared minus 4ac as your friend here, because it saves you a lot of trouble, now I don't have to solve this thing. All right? Now, for elimination, you would just stack these, add them together, multiply 1 by negative 1, add them together, and you get the same exact quadratic. Okay? Make sure, I know that a lot of times, y'all like one method over another method, but there's some problems, if you do elimination, it'll be way quicker. Some problems, if you do substitution, it'll be way quicker. So make sure you're using the one that's going to help you the most.